Solve some linear equations by hand, but you can also do them with a calculator. The first thing with using the x-intercept method, because the solution then will make it equal 0, will be the solution. Rewrite the equation to be solved with x on one side of the equation. Make it x equals. Enter the non-zero side of the equation in the previous step in the equation editor and graph the line in a good viewing window. Be sure that you can see where the line crosses the horizontal axis. Find the x-intercept by using 0. The x-intercept is the value of x that makes the equation equal 0, so it is the solution, and it's where it crosses the x-axis. The value of x displayed in this method sometimes is a decimal approximation of the exact solution rather than exact. We can use math to change it into fractions to convert decimal solution of a linear equation approximately to the exact solution. So solving this equation using the x-intercept method. First, I want the equation everything on one side equals 0. So I'm going to start writing the equation to the left. X minus 3 over 2 plus x over 5. Then this 3 term I want to move to the other side, so I subtract 3 from both sides. And this fraction I want to move to the other side, and right now it's subtracting, so I'll add the fraction to both sides to get rid of it on the right, equals 0. So now I have an equation on one side equal to 0. I'll enter that equation in the equation editor, and the window I'll probably start with is my standard window. Now we're going to graph the equation, and these are fractions, so start out with parentheses, x minus 3, close that parentheses, divided by 2, and then plus x divided by 5 minus 3 plus, again we have more than one term in the numerator, oops, that should have been a plus. We have more than one term in the numerator, so make it x plus 1, close the parentheses for the numerator, divided by 6. And we'll graph this. We have the standard window. We're using the x-intercept method, so do second, trace, which is calc. We want the 0, so we go down to 2, enter, and when x equals 0, this is the y, but it's somewhere between 0, so that can be our x bound, and our right bound, maybe something over here, 10, enter. We'll take a guess at 5, and it will tell exactly x equals 5, y equals 0 is our solution. Done it, and we found out we used the 0 function, and it was here 5, 0. So x equals 5 is a solution to this equation. You can also use the solve a linear equation by using the intersection method. And there you have the two sides of the equation. You put the left side in your equation editor, y equals 1, and the right side is y equals 2. You graph these both on a window that shows their point of intersection, and then find the point of intersection with the two graphs with intersect. And this is the point where the two equations are equal, and the x value at this point is the value of x that makes both sides of the equations equal. So it is the solution to the original equation. We have the same equation to be solved, so we know the solution is x equals 5, but we'll show you how to do that with the calculator. So we'll enter this as y1 and this becomes y2. You'll see that on the calculator. We're doing the intersection method of solving these fractional equations. Let's clear this equation we have right now, and x1 will be our parentheses, x minus 3 divided by 2 plus x divided by 5. And that's our first equation we're entering. Now go down and enter equation 2. We've entered the left side. This is now the right-hand side. 3 minus x plus 1, close the numerator parentheses, divided by 6. And we'll see what our graph looks like here. Here's our first one, and here's the second one. And the question is, where do they intersect? So if we go to second, trace, we can say we want number 5 to intersect. And just first curve, enter second curve. We're going to guess maybe that it's at x equals 4. And we find it out. It is at x equals 5. The y values happen to be 2, but our solution is x equals 5. Here is what we got with the calculator steps. And you can see the intersection right here is at the point 5, 2, and so the solution is x equals 5, because that's the x value where they intersect.